At Felt, we're committed to developing the best carbon fiber bikes in the world. It's important that we push the envelope on the material side, and our commitment to the study of the carbon and composite materials is a huge part of Felt's lineup. It's a phenomenal material for bicycle application, and I think if you're not building things out of carbon now, you're off the back as far as technology. Carbon is the future of bicycles.
Carbon fiber reinforced composites are excellent in applications where stiffness to weight and strength to weight are the #1 design goals. For our bikes, where we need to keep the wheels of the bike tracking in the same plane, and where we want the stiffness of the bike to allow transfer of the athlete's energy into the road, it's essential to increase that stiffness. And the lightweight obviously is extremely helpful for acceleration. It's something that you really feel when you ride our bikes. When compared to welded metal frames and piece formed frames, our molded carbon fiber frames allow us to really tune the ride compliance of the bike. It really allows it to be stiffer, lighter, stronger, and helps the athlete transfer their energy into motion. The two most important physical properties we look at when selecting our carbon fibers are modulus, which is the stiffness of the fibers, and tensile strength, which is the strength of the fiber. So the stiffness, the modulus of the carbon fibers is really measured by, if you were to imagine the carbon fibers being a string, if you were to hang one end and then suspend a weight at the bottom, as you put that weight on there, it's going to elongate. That elongation is the stiffness, the amount of elongation you get for a given amount of mass. Ultimate tensile strength, on the other hand, is if you were to continue to add weights to the bottom of that string, eventually the string is going to break. And that's the ultimate tensile stress that string can take, or the carbon fiber in this case. By developing the layout of the carbon fiber, we select different tensile modulus and different tensile strength fibers to use in different areas within the frame. This can allow us to tune a bicycle's ride so that it will be stiff laterally, it's not going to twist, it'll hold a straight line through the corners, and yet we can still make the bike compliant so that it will absorb road shocks. If you make a bike that's too stiff, or that is ultimately as stiff as it can be, sure, it's going to be great at transferring your power into the road, but if you make it uncompliant, it's going to be very punishing to ride. At Felt, we build our frames with 3 different blends of carbon fiber. We do this to hit different price performance levels. Those are high modulus carbon fiber, ultra high modulus carbon fiber, and ultra hybrid carbon. The high modulus blend of materials that we use in our entry-level carbon fiber bikes are really comparable to the material blends that are chosen by some of our competitors in their high-end frames. The ultra high modulus carbon fiber blend really builds upon what is the high modulus blend. We take that high modulus blend and then add some stiffer materials in there, some slightly more expensive carbon fibers. Because they're stiffer and stronger, it allows us to use less material in total. The tube walls as a result are thinner, which gives a lighter bike and makes the bike ride in a slightly more compliant way. That the thin tube walls damp out some of the trail vibration and really allows a less fatiguing ride. Our ultra hybrid carbon really allows us to select the best materials, the best grades of carbon fiber for specific areas within the frame. In other areas where robustness is perhaps required, we can use a tougher material. And in areas where strength is a factor, we can use a stronger material. This allows us to use less overall, which makes the frame lighter, also delivers the optimum stiffness and ride quality. This year we've introduced nanotechnology. By adding these nanoparticles in between the strings and the filaments of carbon fiber that run within the composite, these little particles can bridge the strings and allow each of them to work better with each other. This increases the stiffness of the material, which again allows us to use less, which makes the frame lighter, or use the same amount and make it stiffer in a different area, and just gives us a whole different way of tuning the frame to deliver that perfect ride.
At Felt Bicycles, all of our carbon fiber frames use a process that we call modular monocoque construction. And simply what that means is that we utilize monocoque, which means one piece, to fabricate the front triangle. Instead of simply taking tubes and gluing them together with lugs or lug construction, we'll actually mold the entire front triangle as one piece. Therefore, we eliminate any stress risers or any redundant material. It makes the frame lighter, stronger, and stiffer. So what does this mean to the rider? It means you get a better riding experience. Your bike will accelerate faster out of the corners, it'll handle better around the turns, and it'll climb faster up the hills. Like I said before, modular monocoque construction means the whole front triangle is made in one piece. There's no lugs, there's no points that are bonded, manipulated, glued together, causing failure or areas of concern in the future. The fact that the fibers run continuously from the down tube to the head tube to the top tube means this whole area of the bike is completely built and solid. This whole area of the bike is solid. This whole area of the bike is solid. It's one continuous part that's molded at one time. There's no secondary process to it. During the manufacturing process, every single carbon fiber frame at Felt goes through a stringent series of testing. Every bike is put on a table and checked for stiffness, alignment, and quality to guarantee that every bike meets our standards.
At Felt, we're committed to developing the best carbon products in the world.